Afternoon. Welcome to a tutorial session for 1.12 quiz, Converse of the Pythagorean Theorem. In this session, we are going to review 1.12 quiz, Converse of the Pythagorean Theorem. Link to the Nearpod is in the chat. Be sure to join Nearpod and let's work together. Here is question 1, and I'm going to go over all the three varieties. Question 1. A right triangle has a leg of 11 centimeters and a hypotenuse of 17 centimeters. Notice hypotenuse is the longest side. Hypotenuse is the longest side of a right triangle. Hypotenuse is this side right across from the right angle. The legs are the smaller, the shorter sides of a right triangle. Notice one of the leg is given to be 11, hypotenuse is given to be 17. And the question is asking what is the length of the other leg? Well, when we learned and practiced Pythagorean theorem, we practiced two kind of problems. The first one was applying Pythagorean theorem itself. That is when we wanted to find sides. We wanted to find the longest side called side C. We were finding hypotenuse for missing side C. And another formula that we used was the converse formula. We use the converse formula when one of the leg is missing. When we are missing side A or B. That is important to note. Side A and B are the shorter sides. Maybe this could be called side A and the other shorter side could be called B. When one of the shorter sides are missing, we are using the converse. Notice when one of the shorter side is missing, side C, the longest side, will be given to you. And notice here, side C is 17. Side C is given. We are not applying Pythagorean theorem. We are applying converse, inverse, opposite of Pythagorean theorem. How do we apply the opposite? Let's see. Normally, Pythagorean theorem states if you square the two shorter sides and add them, you get the square of the longest side. This is what Pythagorean theorem states. But when one of the shorter sides is missing and when we are doing converse, rather than adding, we are actually subtracting. We are subtracting the given longest side, that is C, and we square it. Remember, Pythagorean theorem has to do with squaring numbers. Rather than adding, we do the converse of adding, means we subtract the given shorter side. In case here, I labeled the given side to be B, so I subtract one of the shorter sides, side B, square of that. That gives me A squared. But guess what? We don't need A squared, but we need only A. In order to get A by itself, we will do square root of C squared minus B squared. When this sign is a subtraction sign, we are actually using converse of Pythagorean theorem. And it will help you find one of the shorter sides of the right triangle. Let's get started and plug numbers into the formula and see what will be the length of side A. Side A equals the longest side C, that's 17, squared, minus the given shorter side, squared. And in order to get a by itself, square root this entire thing. Everybody put this in the calculator and see what you get. You can generate the answer in one go using the Desmos calculator. Put in the calculator and I can show you one example in case you are a little confused. Link to the calculator is in the chat for you. Be sure to click the link. I will start with square root symbol. Here is the square root symbol. 17 squared, here is the square root symbol, minus 11 squared. The answer I get is 12.9. 12.96 is very close to answer choice B. That is 13. So therefore, I will pick 13 as the answer to this question. Let me know if anybody has any questions. 12.9 is very close to 13. And therefore, I chose 13 as the answer. Are there any questions? None. Let's move on to variety 2 of question 1. I will definitely write down the two different formulas that we have learned in Pythagorean theorem. First one being the Pythagorean theorem itself. Pythagorean theorem. G-O-R-E-A-N. Quite, nope. Pythagorean theorem. That is how we can spell it correctly. Okay, let's go to the question and see what information is given. A right triangle has a leg of 12 centimeters. A leg is a shorter side, and it is 12. Hypotenuse, the longest side of a right triangle, is 19. That means side C is 19. When C is given, you're not using Pythagorean theorem, you're not adding. In fact, you are using converse that involves subtracting. In order to follow the converse, we do square root of the longest side C, that is 19 squared, minus the given shorter leg squared, and that gives you the missing shorter side. In order to find converse, we do subtracting. The longest side squared minus the given shorter side squared. Everybody put this in the calculator like I showed you. Tell me, what do you get? You can round your answer. Some answers are unreasonable like C and D, because the answer cannot exceed 19. 19 gonna be the longest. Alexis says 14 is a very reasonable answer. Dwayne says 14 is a very reasonable answer. No problem, Samaya. Let us know once you do it. Let me know. Verify the answer. Rania says 14.7 is the answer. Let's move on to the third variety. Remember, the session is recorded. We can anytime be going to the previous questions also. And here's the third variety of question 1. Let's see what's given. A right triangle has a leg of 13 centimeters. One of the shorter sides is 13. The hypotenuse is 21. Going back to the Pythagorean theorem concept, if we ask ourselves, what are we going to do here? We are trying to find converse. Because side C is given, we are not finding C. C is 21 given. That means this question requires us to do converse. Remember, converse involves subtracting. Let's get started. Set it up. Start with your square root symbol. Remember, it's going to be a subtraction. The longest side, hypotenuse, side C, squared, minus the given side squared. All under the square root symbol. Work it out, see what you get. Converse involves subtracting. Subtracting the squares of the sides. Violet got B. Let's see, Dwayne is working it out. Samaya's working it out. Rania's working it out. Dwayne got B. Absolutely, absolutely. Class, are there any questions when we want to find one of the missing shoulder sides? Subtract the squares and put it under square root. And we are about to move on. I do see you guys follow instructions. Are there questions? Zamaya, that makes sense? Rania, how do you feel about the questions? It's in fact Reina. You get a little confused. You know Reina? We have Rania. There's two Ranias. Now we have a very similar name, Reina. Reina is here too. Reina agrees. Move on to question 2. Question 2, we'll do all the 3 varieties. And here's the first one. Question 2 provides you with a right triangle has legs measuring 20 and 28. Both measurements pertain to the shoulder sides. Means hypotenuse, the longest side C is missing, these being A and B. If you think about the 2 formulas you have learned in this unit, in this case, we are going to use Pythagorean theorem because side C is missing. A and B are given. Side A, we can say maybe is 20. You can use it interchangeably. And side B is 28. We are not doing converse because the shoulder legs are given. We're supposed to be using Pythagorean theorem. Pythagorean theorem involves adding the given sides. How does that look like? We start with the square root symbol. Add the squares of the given sides. 20 squared plus. Pythagorean theorem is different from converse because it involves adding squares. 20 squared plus 28 squared. The longest side is missing, hypotenuse is missing. That is when we use Pythagorean theorem that involves adding. Perfect, Canon. I'm so happy to hear that. Let me see what answer you guys are going to tell me for this question. Demira says C. Demira, you are really quick at getting the answer. Raina says C. Dwayne says C and Zamaya says C. Wonderful. Let's move on to question 2. Variety 2. Alexis says C. Here, a right triangle has legs measuring 16 inches and 28 inches. The 2 shoulder sides are given. What does that tell us? We want to use Pythagorean theorem to find the longest side C. And that's why I'm going to mark it green. That is what is needed for this question. The Pythagorean theorem is different from the converse because it involves adding the two shoulder side squares. So let's do square root of, add the squares of the two shoulder sides, 16 squared plus 28 squared. Put this in the calculator, get an answer. And Dwayne says B is the answer. What did other people say? Reina, add the squares. Damira says B. Add the squares and then find the square root. That's how we can work it out. It's supposed to go in the calculator in one go. Okay, 16 squared plus 28 squared and put it under the square root. I forgot to put a little square here, right? It's supposed to be squared. Let's move on to the third variety of question 2. Here we are. A right triangle has legs. Legs are the shoulder sides, 18 inches and 26 inches. So here are the shoulder sides. They are 26 and 18. The longest side, called side C, called hypotenuse, is missing. Let's see what we can do. We are going to use the Pythagorean theorem formula because side C is missing. Be sure to be solving along with me so you can compare your answers. We're going to find side C. In order to find side C, we are going to be using adding. In order to find the converse, we are using subtracting. Absolutely, Zamaya. I agree to Dwayne's answer. Let's do Pythagorean theorem to find side C. I start with square root. I will add because side C has to be the longest. In order to get the longest side, we're going to add to get a larger answer. I'm going to start with one of the shoulder sides, 18, square it, put a plus sign. I'm going to put the other shoulder side, 26, and square it. That's all going to go in the calculator to generate your answer. Let's see what Reina gets. Alexis, absolutely right. 31.6. Absolutely. Damira, absolutely correct. I agree to you. Zemaya, in order to go faster, how about you use the calculator, dump in the expressions that you have. I see that you have the expressions in your mind, right? As you're working. Keep the decimals on and you'll be able to get to the answers. I see 100% accuracy. Everybody who is doing it got the same answer as we did. Wonderful. Now is question 3. Question 3 and 4 are exactly alike. We have to show them which one applies the right triangle and which one doesn't. Which set of numbers could represent the lengths of the sides of a right triangle? Well, be sure to use the Pythagorean theorem to answer this question. And Pythagorean theorem says a squared plus b squared. That means the two shoulder sides, right, A and B, when you square them and add them, should equal to square of the longest side. This is what Pythagorean theorem says. Let's apply the answers to the Pythagorean theorem and see which answer is going to be the best. We start with, let's check the answers. A is here, right? We will pause when we get the right answer. A says 6, 7, and 8 are the sides of a right triangle. Let's see if that is correct. I'm going to put an A, so you know we are checking answer choice A. The shortest side is 6, so do 6 squared, put in the calculator, plus 7 squared, the other shorter side. Does that equal 8 squared? Try it in the calculator. 8 squared is 64, right? Does that equal 64? If it does equal 64, it is. They can be sides of the right triangle. 6 squared plus 7 squared, does that equal 64? 8 times 8 is 64. Put in the calculator 6 squared plus 7 squared. Does that equal 64 or 8 squared? It did not equal 64 for me. What did you guys get? For me, Dwayne, it didn't equal 64. It didn't. But I want one that will be, right? I'm going to try the next answer. Let's try B. The two shorter sides in B are 16 and 32. So let's do 16 squared plus the other shorter side, 32 squared. What should that equal? Do that math in the calculator. That should equal 36 squared. Let me try it in the calculator in front of you, and you'll get some good. Oh, Alexis already says it didn't equal. Alexis, you're too fast. Here we are. Did not share the right screen. Let me try again. This is what we're supposed to be doing. So the shorter sides are 16 squared plus 32 squared. Does that equal the longest side square? Do the two equal? Oh, answer choice B is not correct, right? Because the two are not equal. A squared plus B squared is not equal to C squared. B is not good. Let's try C. C, the shortest side is 5, so I square that. The next shorter side is 12, and I square that. The longest side in answer choice C is 13. When I square that, see, the two shorter sides squared equals 169. The longest side squared is also 169. It creates a right triangle. That's how quick we can be using the calculator. It's supposed to be 32 squared. So, well, notice B did not create a right triangle, but C did. C did create a right triangle. If you do 5 squared plus 12 squared, you get 169. And 169 is also 13 squared. Let's move on to the next variety of question 3. Here are the numbers, right? Let's try it out in the calculators. For a squared plus b squared equals c squared. We can also color code our work. I will try a first. In the calculators, we want to put in 7 squared plus 9 squared. And check, does that equal 11 squared? Does that? I will do these answers in the calculator for you, and we will be able to figure it out. Okay, this is question 3, variety 2. I'm going to share my calculator screen with you so you can follow along. 7 squared plus 9 squared is, let's see, plus 9 squared. Is that equal to 11 squared? No. So answer choice A is incorrect. A is not a right triangle because the two shorter side squares is not equal to the longest side square. Let's try B. Answer choice B, the two shorter sides are 8 and 15, so 8 squared plus 15 squared. Is that equal to 17 squared, the longest side? Yes. 8, 15, and 17 are creating a right triangle. You all see that? 8, 15, and 17 is creating the right triangle because the two sides are equal. Does anybody have any questions? Does it make sense? Yes? Let's move on to the third variety. Here's the third variety of question 3. Which set of numbers could represent the lengths of the sides for right triangle? I will apply the Pythagorean theorem. I'll do the squares of the shorter sides and see if that equals to the square of the longest side. I will use 7, 24, 25 first, then I will use 8, 9, and 10 next. Let's go to the Desmos calculator and try out the numbers. Answer choice A says the two shorter sides are 7 and 24. So 7 squared plus 24 squared. Is that equal to 25 squared? It seems to be working. I did not even have to try other answers. 7, 24, and 25 are a right triangle. That is the right answer. So we did not even have to go to other ones and we can just pick A. 7, 24, if this is side 7, this is side 24, that will be a side 25. It will be a right triangle. Is it making sense? Let's move on to question 4. Question 4 is like question 3. Very similar. And here is first variety, question 4. Which set of numbers could represent the length of the sides of right triangles? Think about the two shorter sides squared and added equals to the square of the longest side. We will try 9, 10, and 11 in the calculator. Let's get started and try it out. The sides, the shorter sides are 9 and 11, 9 and 10. I do 9 squared plus 10 squared. Is that equal to square of the longest side 11? Not equal. Answer A is not a good answer because 9 squared plus 10 squared is not 11 squared. Move on to B. B says the sides are 3, 4, 5. I did square of the shortest side 3, add to the second shortest side 4. Is that equal to 5 squared? Notice that the squares of the shorter side is 25. The square of the longest side is also 25. B is a working answer. We can choose 3, 4, 5 as our Pythagorean triplet. This is a working answer. Let's move on to the next variety of question 4. 7, 24, and 25. Put that in the calculator like this. 7 squared plus 24 squared. find the answer. Does that equal to 25 squared? Let's check it out. We'll go to the calculator again. We'll put in the numbers and try it out. The shorter sides are 7 and 24. So 7 squared plus 24 squared. 625 is going to be a working number because 25 squared is 625. Right? So 7, 24, 25 does create a right triangle. It is a working answer. Notice that this is 625. So is 25 squared 625? Definitely the answer is A. Because 7, 24, 25 is going to create a right triangle. Let's move on to question 4, variety 3. Let's try them out. 9, 40, 41. We will try to put in the calculator 9 squared plus 40 squared. Can you guys tell me how much is 9 squared plus 40 squared? Then tell me what is 41 squared, the third side. I know. Oh, Dwayne says 1,681. Dwayne, is 41 squared also 1,681? I think so. Then I can say A is the answer. Because 9 squared, 40 squared added together is 1,681. Then 41 squared is also 1,681. That is question 4. If you think it's time for you to hop off, feel free to hop off. I will do the entire quiz because it's a recorded session and I want to share out with others who are not attending. Question 5, variety 1. Let's see the question. The question is talking about a diagonal length of a rectangle is 21 inches. And the length of the rectangle is 8 inches. Well, the triangle is not needed here, but for safe side, I did put in one. Here is a rectangle. We can make it a little lighter color. The diagonal is side C. The diagonal of a rectangle looks like side C, and it is 21. The length of the rectangle is 8 inches. This length means the longer side. So in a right triangle, it can look like this. Diagonal is 21 and the length of the rectangle is 8. Which measurement is closest to the width of this rectangle? The width is missing. Probably side A, B, one of the shorter sides is missing. Now I know that the shorter side is missing. That means I apply the converse. I apply the converse formula. And the converse formula applies subtracting. Keep that in mind because the shorter side is missing. Let's see how we can apply the converse formula. Start with square root symbol. The longest side squared minus the given shorter side 8 squared. Everybody put the expression in the calculator. Tell me what you get because we will apply converse. Converse involves subtracting. Longest side squared minus the given shorter side squared. Everything under the square root symbol. What did you get? Dwayne says got B, 19.4. Dwayne, 100%. You are at Mastery for this quiz. Wonderful. Tamara, is that what you got? And Zamaya? That is the right answer, 19.4. Raina got that. Let's move on to the next variety of question 5. The diagonal length of a rectangle. We need a rectangle again. Okay, here is the rectangle. The diagonal length means this way. The diagonal length is 19. If I think about the right triangle in it, this diagonal is 19. And the length of the rectangle is 7. This side of the rectangle is 7. This part of the right triangle part is 7. Right? This is what's given in the question. That the diagonal length of a rectangle is 19 inches. And the length of the rectangle is 7. So which measurement is closest to the width, the W, the width of this rectangle in inches? So this little piece is missing. We want to be finding the converse of Pythagorean theorem that involves subtraction. Start with your square root symbol. And when you subtract, you want to put the longest side first. 19 squared minus 7 squared. Everybody solve the question. Tell me what you got. Damira got B, 17.7. That is correct, Damira. Let's move on to the last variety of question 5. And here we are. All the questions are quite same, just the numbers they're using are slightly different. They're talking about a rectangle. And the question reads and says, the diagonal length of a rectangle is 25 inches. This diagonal length is 25 inches. Whenever the word diagonal is being used in Pythagorean theorem, it pertains to hypotenuse, the longest side. The length of the rectangle is 9 inches. So the length is 9 inches. One of the shorter leg is 9. Which measurement is closest to the width of this rectangle in inches? The width is missing. This one of the shorter side is missing. Use the converse formula that involves subtraction. Start with your square root symbol. Whenever you're subtracting, write the bigger number first, 25. Square it. As converse means minus the given shorter side, that's 9. Square root of 25 squared minus 9 squared. Alexis gave me the answer to be C. Damira says C. Did anybody get any different answer or y'all agree to C? Well, I'll pause the recording at this time